In this video, we will look at an introduction to nature of roots and how it fits into other sections. And so basically, what you've probably learned by now is this quadratic formula for working out typically the x-intercepts when you're factorizing the solutions for x. And if you can factorize something, then great, you go and factorize it and get your answers. But if you can't, then you can use this quadratic formula. And then further to that, if you just looked inside the square root, then that would give you the answer that you need for the nature of roots. And so without having to do the entire quadratic formula, you could just look at what's happening inside the square root, the discriminant. And for example, if that was negative, just that inside here, then you'd know you're not going to get roots because you can't square root a negative. And so using words, we would describe those roots as non-real. So that's how it kind of fits together. I find it helpful realizing visually what does that mean for a graph. And so I'm going to look through those as well. So this is your discriminant. We find it inside the quadratic formula in the square root. If the discriminant is less than 0, so if we had a minus inside here, we say that the roots are non-real. What does it mean visually? It means you'd have a parabola like this where it wouldn't have any x-intercepts. There'd be no touches. If it was bigger than or equal to 0, then we would describe the roots as being real. They do exist, but in a sense, they could be any numbers. If very specifically the discriminant equals 0, then we say they're equal roots, which just means the roots, the x-intercepts would be the same. So it will be the exact same number. So it's almost like it happens once in a sense. And then if the roots specifically are a perfect square, so you finished a question and you got an answer like that. You finished a question and you got an answer like this. So if it's something squared or numbers that you recognize, 5 squared is 25. If it's a perfect square, we describe those roots as being rational. Obviously, it could be that you have roots that are real and rational, because, for example, 25 is bigger than 0, so it's real, but it also does happen to be a perfect square, so it's rational. And you could go further to that and say the roots are unequal. And so that's how the pictures link up with the working out the discriminant and describing the nature of roots. What's helpful to do is, as two simple methods, is times everything out first. If you've got brackets in that, take it all to one side and then group just your x squared terms and whatever is left, because that becomes your a. Take out just your x and whatever is left is your b, and then any other terms that don't have x's, let's just call them the randoms, will be your C. The last thing to say is sometimes you'll get questions where you're given a trinomial type of vibe, or where you had to take out the x squared, the x, and the randoms, and that will look like this. And to do your actual nature of roots, you'll dive straight into what we've talked about. But sometimes you'll get questions where they actually give you the entire answer, and they say something like that, and they say show that the roots are non-real. Which values of p will the roots be non-real? Then if they've given us the whole quadratic equation, then we know that the nature of roots is just what's inside the square root, like I've highlighted here. And so if they want the roots to be non-real, I'll show that I know what that means. And then the discriminant is just what's inside the square root. And so these questions actually become the easier options of what we work out. So either we get it like this and we can dive straight in, or we get it like something like this, and then we work just with the A, the B, and the C. In this example here, I've actually worked everything out, so this is getting the actual solutions. But if I had to do the nature of roots, let's see what these would be. So I would start by saying, I don't know what they are, so I just say discriminant equals b squared minus 4ac. B, here it is, it's minus 2. A is the first term, that's 3. and c is the last term, which is minus 4. If I work that out, that becomes 4, positive 4. This becomes positive 12 times 4 is 48. And so you end up with your answer of 52. How would I describe the nature of these roots? Because it's bigger than 0, I would say they're real. If you wanted to be seriously fancy, this is not a perfect square, so you could say it's irrational. And again, if you want to be really fancy, it's not equal to 0, so you'd say it's unequal. And for your reference, visually, you'd get something looking like this. You'd get 2 different roots, and just looking at the graph, I can see it's happy, so it would look like that. I hope that that was helpful just as an introduction to the nature of roots. We'll dive into a lot more specific examples and some really tough ones just to cover everything in this video series. If you found this video useful, please like it, subscribe to our channel, and share it with your friends. Thanks.